praise to the Almighty. Very good morning to all. I am Sheik Mydeen, Assistant Professor, Department of Information Technology, Haji Karatarawatar Havdiya College, Uttamapalayam. And today we are going to discuss about the number system and codes in digital principles. First, we know that the data. So the main objective of this presentation is how the data is to be processed within the computer. So what is mean by the data? The data may be the numbers, text, audios, videos, animation, graphics, images, pictures, like that. So all the data should be converted into the digital format. The digital format knows only zeros and ones. So first, the working principle of understanding the working principles of computers. The computer is a programmable electronic machine that allows only zeros and ones to process all kinds of data. So the objective is to be reached by using the number system and the codes. So here we discuss about only the numbers and a few codes about the processing capacity of a system. So first we know that the number system. So there are four number systems are widely used in computers. The first one is decimal number system. It's a real world number system which includes 0 through 9. The total number of digits in the number system is 10 numbers. And the second one is a human understandable and real world number system. And the second one, binary number system. So as the name implies, which is includes only two numbers, zeros and ones. So we know already the computer can accept only zeros and ones. All kinds of data should be converted into zeros and ones. So which is in binary number system. So the binary number system called as a machine language or machine understandable language. So the number system includes zeros and ones, and third and fourth octal number system and hexadecimal number system. So both the number system are called as an intermediate number system. The difference between the real world number system, the digital number system and binary number system. So here the octal and hexadecimal are intermediate number system between them. So next we discuss about briefly in the number system. The decimal number system, we already know that the 10 digits include 0 through 10 and the binary zeros, 0 and 1. The octal number system, as the name implies, the octal denotes 8 numbers. The 8 numbers ranges from 0 through 7. The octal number doesn't consisting 8 and ninth digit. So next one is the hexadecimal number system. So the hexadecimal number system consisting 16 numbers. The 16 numbers can be divided into two parts. The first one is decimal 0 through 9. So after the decimal digits, we don't have no numbers. So that we take alphabets. So the first six alphabets, including the hexadecimal number system, that is A to F. So all the number system can be used to convert the numbers into zeros and ones. So why we need an binary number system? So binary number system, because we know that the computer accepts only zeros and ones, all the electronic machine knows only on and off state. So that we have to convert the any kind of data is in zeros and ones format. So then how to identify the number, which is the number is decimal, octal, binary or hexadecimal. The number is identified by the base number. The base number represents the total number of digits in the number system, as well as the number is identified by using the symbols like B for binary, O for octal, H for hexadecimal, and D for decimal numbers. The decimal number representation is in here. So the decimal number represents 10 to they have the two parts. The first one is integer part. The integer part is described from the right to left, from 10 to the power 10 to the 10 power 1 to 10 power n. In the fractional part starts with the 10 power minus 1 to 10 power minus n. So in this example, the 735 is a decimal number. The decimal number describes as follows. Next one is the binary number system. The binary number system, which is converted to the decimal number system by using the 2 power 0 through 2 power n. So it's a decimal number, the same as the binary number. The binary number having two parts. One is integer part and another one is floating point representation or imaginary part. So the integer part starts from left to right. We make a 2 power 0 through 2 power n. So in this in mathematically, the formula is a reminder 2 power anything power 0 is equal to 1. Here 2 power 0 is equal to 1. Next one is the conversion possibility of the number system. So we have know that the decimal and the binary number system as well as octal and the hexadecimal number system. So we have the 12 possible conversions available here. So binary number system may be converted to decimal, octal or hexadecimal, and decimal number system converted to binary, octal, and hexadecimal. And then octal number system converted to decimal, binary, and hexadecimal number system. And the hexadecimal numbers can be converted to decimal, binary, and octal number system. Each conversion has its own logic and implemented to converting the binary digits. So these are the example of converting the decimal to binary. So decimal to binary conversion is a very simple. The given decimal number is divided by 2. So until that the result is 1 or 0. So we collect the reminders from bottom to top. In case of fractional part, the quotients will be collected from top to bottom. The next one is octal number system. So octal number system already you know that the ranges from 0 to 9 are identified by the base number 8 or base symbol O, which doesn't consisting 8 and 9. Next one is the codes. So sometimes till now we deals with only numbers. So suppose that the alphanumeric characters are available to process in the processing. So the codes in the image, they have lots of codes as available here. We have only discussed about the BCD, XS3, Gray code, ASCII, and EBCD IC. So this is described one by one. The classification of codes is about the classification weighted codes, non-weighted codes, reflective codes, sequential codes, alphanumeric codes, error detection codes are available. The first one is BCD codes. The BCD code describes only 10 numbers 0 to 9. The BCD is for binary coded decimal. Each and every digits of a decimal number system equivalence of converting the four binary digits like the 9 is converted to 1001. The maximum number is 9, 1001. The minimum number is 0, is indicated 000 and 0. The next one is XS3 code. So we have simplified the XS3 code. So the binary digit adds 3 in the LSB, least significant bytes to most significant byte. So here the minimum or maximum range is 0 through 9. So maximum number 9, we have find the XS3 equivalent of 9 is 12. So 9 plus 3 equal to 12. The 12 is indicated in binary format, that is a 1100. Suppose that they have indicate the binary into the hexadecimal number, it indicates C. So the maximum number 9, after that there is a no number for XS3 codes. So the given numbers are separately and added each and every digits in with 3. Next one is gray code. So gray code is a type of code which is used to replacing or misplacing the zeros and the ones. So we have using this gray code for the security purpose. When we are transmitting the binary digits into the device to device, we have follow some encryption or decryption basis so that the gray code is used to that. The gray code is the basis of the exclusive OR gate. So which is in logic gate, the exclusive OR gate provides the high output when the input possibility having odd number of ones. So this is the conversion part. There is two conversions available. The first one is binary to gray code. So first one is the first digit is almost same as the resulting, and the second position is calculated by using the first and the second position. The third position is calculated by using the second and the third person, vice versa. So then the second conversion of gray to binary code. In the reverse one, the result is added or exclusive or with the next position. The next one is alphanumeric codes. So alphanumeric codes, ASCII. So the abbreviation of ASCII is American Standard Code for Information Interchange. It's a 7-bit code labeled as X0 to X6. The 7-bit code are not accessed or not processed by the machine or computer, so that we can add a single bit in the MSB, most significant byte, 0. So the 8 bits are converted to the 8 bits are represents the any alphanumeric keys or special characters or numbers or direction keys in the keyboard. So the total number of digits in the ASCII is 2 power 7. So the 2 power 7 indicates 2 power 7 is equal to 128. The 128, the maximum of 180 characters available in the ordinary keyboard. So the 8th bit is a binary parity bit. The parity bit is used to indicate the sign of the value in the measure. So initially the parity bit is 0 for all the times. When we are using the signed bit like -5, -6 like that, so we have indicated the 8th bit in first version. And another purpose of the parity bit is for security purpose. So we can in future we could study the parity generators and checkers for this parity bit. So ASCII is a table which is consisting rows and columns. The rows starts from 0000 to and ends with the 1111, and the column is starts with the 0002 and 111. So the table having the reference of each and every keys in the keyboard. And the next one is EBCDIC, extended binary code interchange code, extended binary coded decimal interchange code, which is this 8-bit. The comparing with the ASCII is a 7-bit. Here the EBCDIC is a 8-bit code. So that the 2 power 8 equal to 256 characters, maximum 256 characters available. In case of the most of the characters is a reference for reference in future. So same that the table consisting the rows and columns for 4-digit binaries. So most of the boxes are empty for a future purpose only. So in this class, we have discussed about the number systems and the codes. The main objective of this exploration of presentation is how the data could be processed in the computer. So I think all of you understand about the number system and the codes. Thank you.